This question, we have x's in the base and the power. So you know what that means, right? When we have x's base and power, base and power, when we have x's in the base and the power, we've got to L in both sides. That's how we always deal with x's in the base and the power. So we know that's coming. And then at the end, e both sides to get rid of that L in. That's always what we do at the end. Okay. So let's take this function. We'll bring back in the limit in a minute. Let's just go y equals 2x to the 9 over x power. And we're going to L in both sides. It's always pretty much our first step, how we deal with x's in the base and the power, because then that power jumps down, right? So we get ln of y is 9 over x in the front now of the ln. It's the greatest quality of logs. You can bring them down to the front. Okay. So now what? Let's bring back in. Let's don't forget there was a limit from the beginning. Say that, okay, the limit x goes to infinity. Now, what do we do with this? Well, if you plug in infinity right now, if you plug in an infinity right there and an infinity right there, what are you going to get? You're going to get 9 over infinity times natural log of 2 times infinity. 2 times infinity, that's 0, right? 9 over infinity, 0 like 9. Remember, infinity is like, a million, a billion, a trillion. So you say, okay, I'm going to take a candy bar, break it into a million, a billion, trillion pieces, and give you 9 millionths of a candy bar, 9 billionths, 9 trillions. That's like basically no candy bar. It's cut into infinite pieces. Getting 9 of them is still getting nothing, basically. Times ln of infinity. So that's 0 times infinity. Now that's indeterminate, meaning we can't determine what that is. That's not clear. We think, yeah, it is 0 times anything 0. Yeah, it's not really 0, though. Remember, it's just really tiny. It's just the dust of the candy bar, super small. So it's a really tiny number. We call it 0, but it's headed to 0. Remember, limits where you're headed. It's headed to 0. It's really, really, really tiny. It's getting really, really, really tiny. And this is getting really, really, really big in infinity. So what's something really, really tiny and something really, really big? Well, it kind of depends how fast they get there and a lot of other things. It's just indeterminate. We're not clear. So, okay, this is where we remember, oh, yeah, yeah, that's right. What I could do is I could do Lopi. They didn't say Lopi, but I should do Lopi. Meaning, whenever you have that, you want to go, oh, okay, watch what I can do. ln of 2x over x over 9. I flip it to the bottom. Remember, dividing is upside down, multiplying. If you're multiplying by 9 over x, that's the same as dividing by x over 9. You know that, right? Like if you take 10 divided by 2, that's 5. That's the same thing as 10. This is a scribbled 2 down here. 10 divided by 2 is the same thing as 10 multiplied by a half. Dividing by 2 is the same as multiplying by the upside down of 2. It's 5 either way. So dividing is just upside down. Multiplying, so multiplying by 9 over x is the same as dividing by the upside down. Now, what's the great? Okay, so what? What's the great? Well, now when you plug in infinity and infinity, what are you going to get? Well, you're going to get ln of infinity on the top and infinity over 9 on the bottom. What's that? Infinity over 9 is just infinity, right? ln of infinity is also infinity. You get infinity over infinity. Okay, great. So what? Who cares? That means we can do Lopi. Remember? So I think I'll probably add Lopi here. So use L'Hopital. Use L'Hopital. So when you use what is L'Hopital? That's when you have 0. Oh, so when you have 0 over 0 or infinity over infinity, then you can take the derivative of the top and the bottom separately. Separately being the key word. Yeah, that's what L'Hopital's rule says. When you have 0 over 0 or infinity over infinity, you got to get that. That's a requirement, and we just got it. Then you can take the derivative of the top and bottom separately, not quotient rules, separate derivatives. So we just got infinity over infinity, and I go, oh, that's great. So now use L'Hopital's rule, which means what? Which means keep that limit in the front still. But now we can take the derivative of the top and the bottom separately. Okay. Now, how to do the derivative of ln 2x? Well, you know that. It's 1 over the argument. But since the argument's not a simple x, it's times, chain rule says, okay, don't forget about me. How's the derivative of the other? What's the derivative of 2x? 2. Okay. Now on the bottom, how do you do that? Well, that's a 1/9 x, right? So his derivative is first power, comes on down, be 1/9, and then subtract 1 from the power. The x just goes away. It's just 1/9. So notice I did the derivative of the top and bottom separately. Top and bottom wasn't quotient rule. I didn't, quotient rule, they take turns, divide by the denominator squared. I avoid quotient rule whenever I can. No, I didn't do quotient rule. I did L'Hopital, which means, right, we normally go equal sign with an H, saying we just did Lopi, which means we did the derivative of the top separate and the bottom separate. Okay, great. Now what? Well, now good things happen. This is 2 over 1, so these will cancel. Take that 1/9 and flip it up. Again, dividing is upside down, multiplying. So we have the limit, x goes to infinity. This is going to become a 9 over 1 on the top times 1 over x. This is still 1 over x. 2's are gone. There's no more denominator. It's gone. So then this is the limit. X goes to infinity. 9 over x. Now what's that? 9 over infinity. What's 9 over infinity? It's 0. Remember, infinity is like a million, a billion, trillion. If I say, hey, I'm going to give you 9 millionths of a candy bar, that means the candy bar is cut in a million or billion or trillion little pieces to give you 9 of them. That's basically nothing. There's no candy bar. So our answer is 0. Careful, careful. Don't forget. When x's are in the base and the power, we got an e here at the end, right? Whenever you got x's base and power, we ln both sides, and then at the end we got e because the left side's really just ln y right now. It's not y. Kind of stopped bringing it down, but I should have brought it down right here. I should have kept bringing it down, I guess. Ln y. The left side's ln y. The left side's ln y. The left side's ln y. So we have ln y is 0. And so the last step we're going to e both sides. Boom. Y is e to the 0. And what is that? What is e to the 0? What's anything to 0? 1. Y is 1. And so there we go.